Всем привет! Я сегодня вам расскажу про защиту от перехвата GSM.
Hi, today I will talk about protecting your mobile phone from capturing GSM signal. Let's start from the standards that the mobile phone uses. What is GSM? Well, there are three generations, 2G, 3G and 4G. Now whatever I will be talking about will concern 2G only. Why are we so interested in 2G? 2G was put into operation, it was designed late in the 1980s and put into operation early 1990s. Now it's most popular with the widest coverage. It is more than 20 years old, so it does have some safety security problems like one-side authentication and unscripted connection possibility. Let's see how it works. So we have the phone and we have the base station. On the SIM card you have the key write, which is not extractable and which is used for identification. On the operator side, a triplet is generated, a random number, and the key, encryption key. The base station will transmit this random number to the phone, which then sends it to the SIM card, which returns two values, the res and which operator checks and to identify the subscriber. Then it sends out a command for star encryption. With it is using the KC key. And as you can see from this algorithm, there's nothing that prevents the intruder from substituting the base station and bypass the encryption. We have I51, I52 is not used, I53 is more reliable, but I51 can be cracked in a second using professional decryption devices. So what the intruder can do in using this vulnerability, first of all, he can hear what we say over the phone. So in order to do the interception, we will have the three blocks: the virtual base station, decryptor, and the emulator. So the telephone is connected to the virtual station. The emulator of the mobile phone, what it does is connecting the telephone to the operator. For this purpose, the encryption code must be cracked with the KC, which does the session encryption. So this interceptor as a full-scale system is quite expensive, but there's a simpler version which looks like this. It has the virtual station, and it uses internet connection to proxy the call. This option has some limitations. It's a case of one-side connection through this IP. OIP, the subscriber can make a call only. In the second option, using this vulnerability, there's an IMSI catcher and the signal blocker. IMSI catcher blocks signals and turns them back. So the subscriber goes back to the operator's real network, but we already have the identifiers. The second option is blocking the signal. The blocker works the same as IMSA catcher, but after authentication it accepts the subscriber that sits in the with the virtual station, and no services are available. How can we find such virtual base stations? There are some signs. Okay, we can look into the network, and they will be seen. And there's also authentication algorithm, which is more complex, and there are some special features. What I described so far is a simplified model. So first of all, we look at the power of the signal to switch the subscriber to another node. The virtual one must be more powerful, and there's a KC2 coefficient which is used by the operator. So, for example, if you enter the metro station in the rush hour, the load will be high and the signal must be more powerful. So the virtual station does the same and redirects the subscribers to itself. So the operators do not have this traffic, and there will be paging requests that are responsible for inquiring or requesting the connection channel. And there are also other special features like lag, location area code, absence of some servers like edge, for example, requires a different type of modulation, so to implement it will be more costly. In order to switch over, instead of using coefficients, we can just turn down the nodes of the real operator. So another special feature of the protocol is absence of the neighbor. So all the features marked with the white color, highlighted in white, is something that you can receive passively without interconnecting with the network. There are also other signs that we can look for, like absence of encryption and opening of channel without transaction. So how can we use these criteria to try to find the malware? So first tool we have is the SDR. SDR is the software that can tune to the frequency that we need and decode the signal and use it through the computer. Another option is use BMB processors. Here I show the most important, most popular suppliers. If we use SDR, what is the outcome? The outcome will be a spectrum and broadband channel. SDR cannot communicate with the base station. But there's another strong point with SDR, because we can view the spectrum. The GSM standard offers some parameters of the radio signal that must be met for electromagnetic compatibility. Not all virtual stations comply with this GSM standard in terms of these criteria, so we can also use this to look for the signs. So another feature is the possibility to parse the communication from the broadband channel. So this is a kind of message that we will see. Down there you see an open message from broadband that tells us about the criteria of switching to the cell and identifier. If we use Qualcomm, the benefit is to be able to open the allocated allotted channel and connect to the cell, and we can also have more information to communicate with Qualcomm. The software was implemented based on Android, which opens the interface of Qualcomm, and based on the message thus received, it will see whether the base station is legitimate, the one that it is connected to, which communicates with the mobile device. As we analyzed these features, we added weights to each of them, and as soon as the weight reaches a certain point, we can decide whether it's a virtual or real station. And also, as the channel opens, we look at the HS encryption and some other parameters. So this is already an area of active testing, but this is where we are really very much limited with the Qualcomm diagnostic protocol, which is not documented. There are some programs like QCAT, which parses Qualcomm logs, but there's no official documentation. It's all unavailable, closed, so we use the data otherwise. Well, this is all more or less. Thank you. I can take questions, if any. I think there is a microphone in the room. The next generation will give more protection. Right. Whatever I said now is only about 2G. The later generations use two-side authentication. So it's not so easy anymore to intercept. It will take some cracking of the encryption, or there's a possibility of downgrading. So they will force you to drop down to this to G2, right? No, but yes, but we are not yet looking at that. Another thing with 3G is a CM catcher attack, so we can get the identifier even without authorization. Another question. What about the modern computation system? Is if we have a good spectrum table and interceptor, maybe that will be enough for the hacker to get the data and be undetected. What data do you mean? All the traffic between the telephone and the GSM base station or cell. Yes, that may be enough, but first, what you say about computation powers is true for I51 encryption algorithm, but you need to understand the operator uses load balancing, and the subscriber will be moved between the stations. So you need to have the hopping map, which is not encrypted for SMS, but is encrypted for voice communication. So we need to somehow capture that. Otherwise, we need to have a broadband channel to get all the GSM traffic. But this is more expensive because it takes broader band connection. Is it possible for anyone to control the connection parameters with very limited possibility? It depends on the vendor. For example, the Qualcomm option allows you for some standards to force the reconnection to the base station. The SIM card would also include have a list of or a blacklist of cells which are not allowed. So we can, of course, we can do some controlling, but very limited. MCI catcher is also known as Stingray. It's there's a kind of encryption, yes. There are quite a lot of software products, including for Android. What was the motivation to do your own, to make your own? How is it better from others? You know, when we started all that, it was the only one on the market, and it didn't really work. In December there was a Snoop's presentation. Since December, I think they made some more development, and they didn't have the wrong right flags, but there have some weaknesses as well. So the motivation is there to do work on our part. They're saying that they took them a lot of time to collect statistics. They have GSM map project, as they call it, and they say they want to reduce the number of false flags. Any statistics for our country? No, it's too early, and it's still under testing, and seeks approval. Is it possible to avoid reconnection from GSM to 2G? Yes, it is possible to preclude this. So is it telephone level software? Yes. You can disallow a standard that you don't like at the mobile device level. I think there is one more question over there. Talking about Qualcomm, you also mentioned MTK. How is it different for MTK? There's also Highway and Samsung platforms, basebands of the companies. Is it easy to work with them? Another question, do you have any plans to put the Android software into Play Market? About Qualcomm and MediaTek, the difference is that in the case of Qualcomm, the documentation is more closed. Market-wise, Qualcomm is more about top models, while MediaTek is used a lot in cheaper phones, like Chinese-made, and it's easy to change email. Qualcomm does not allow that so easily. And also the difference is that as we use diagnostic interfaces, the formats of messages is different. To do the implementation of MediaTek will require doing it from scratch. We do have algorithms, but the implementation will be very different. So to the second question about the Android market, the licensing arrangements is not yet clear. It may be an open source project or commercial one. It's still undecided. Oh, that's it.